Hello everyone, welcome to my data structure series. This series we are going to understand why data structure is the number one skill set for placements. Many students think data structures as just another subject for passing their exams. But here is the truth. This one subject decides whether you get good placements or you get rejected. So if you have ever felt like I know programming languages like C, C++, Python or Java, but still I'm not able to solve problems, or if I don't know where to start coding, this series is exactly for you. So we will learn what is data structure, why data structures are important, we'll solve problems using C, and then we will try to learn linear and non-linear data structures in the series. So what is this data structure? It's nothing but how you store data, how you organize data, and how you use it efficiently. Imagine your phone contacts. At least 500 to 1000 contacts or greater than 1000 contacts will be there in our phone. If everything is stored randomly, finding one number becomes very slow, very tedious. But since your phone contacts are organized, you can find it very easily. This organization is nothing but data structures. To keep things simple, now this organization, I mean it to be data structure. Modern phone contact systems will use combination of advanced data structures and algorithms to handle these thousands of records while providing instant search results as you type. Again, the choice of the algorithm depends whether you are searching by name, searching by number, or looking for specific suggestions. Done? Right. Without data structures, what happens? Let us check out. I take an example of finding duplicate elements in an array. Without data structures, you need to try random loops. Almost time gets wasted and your code becomes messy. With data structures, you immediately think, yes, I can use hashing, so problems will be solved faster. So very important for placements is, let me be very direct. Companies don't care if you use syntax. They care if you can think. Even in placements like coding rounds, online tests, and technical interviews, all of them test data structures. So, what is the real advantage of learning data structures? You start solving problems faster. You try to write optimized code. You stop guessing and start thinking logically. The confidence level increases in interviews, and you can even learn advanced topics like AI, ML, deep learning easily. So the real problem with most of the students is that most students fail not because they are weak, but because they never understand basics like pointers. They would have memorized code instead of understanding. They would have rushed into problems without actual foundations. So foundation is very important. So what you can expect from this series? The series will start from absolute basics. We will build concepts very slowly, understand visually, and then also code the concepts in C. Right? Let us take another very simple example. So this is an example where I'm marking attendance for students. So imagine you are maintaining attendance for a class. You have student attendance like day wise, present, absent, present, absent, present, absent, etc. Instead of writing attendance separately for each student, we store everything in a linked list, single list kind of thing. So I assume this list to be an array since we have not talked about linked list now. So I assume this list to be an array. This list stores multiple values in an organized way or organized pattern. Now imagine you didn't use an array. If you don't have an array, you need to write attendance randomly in a notebook. There won't be any ordering, no indexing. So now if I ask you, was student present on day 4? You will search line by line and get confused. you will take a lot of time to answer me whether the student is present or absent on day 4. But with an array, each position has an index, meaning day 1 is index 0, day 2 is index 1, day 3 is index 2, etc. Now if I ask you what happens in day 4, you just jump to position 3 and find out the answer and tell me the answer in seconds. Arrays give you direct access to data, but arrays also have limitations. The size of an array is fixed. Inserting in middle is very slow. That's why we learn more data structures like lists, stacks, queues later. So this is what is the advantage of using a simple data structure. Right. Let us try to define data structure. There are a lot of definitions for a data structure. One formal way is to define a data structure as a systematic way of organizing and storing data in a computer so that it can be accessed and modified efficiently. Also, a data structure is a specialized format for organizing, processing, retrieving, and storing data, enabling efficient access and manipulation. Also, it could be defined as techniques used to organize data in such a way that operations like searching, insertion, and deletion can be performed efficiently. Right, so we saw formal definitions of a data structure. What could be the types of data structures? There are two major types of data structures: linear data structures and non-linear data structures. Linear data structures are structures where data elements are arranged in sequential manner, one after another. Each element has a single predecessor and a successor, except the last element. You can imagine a linear data structure as people standing in a line, one behind the another. Whereas a non-linear data structure, the elements are arranged in a hierarchical pattern or an interconnected way. For example, your social network. One element can be connected to multiple elements, like a family tree or a social network. One person connects to multiple persons. So there are two important categories. One is data items arranged in a linear fashion sequentially, which I call it to be a linear data structure. The second, where data elements are arranged in a hierarchical way, I call them to be non-linear data structures. Right. Arrays, stacks, queues, and linked lists are examples of linear data structures. Look, in an array, items are arranged in sequential pattern. A stack, you just consider plates arranged one above the other. So the last in will be the first out. The plate that you put the last will be first out. That is stack. Queue. People standing in a queue. First in will be first out. Linear, sequential arrangement of data. Linked list. Train is an analogy for linked list. So all these are examples of linear data structures. Right. What could be non-linear data structures? Graphs, trees, hash tables are examples of non-linear data structures. Just look at the pattern here. One node is connected to multiple nodes. Yes, so this is the hierarchical arrangement of data elements. So such structures, we call it to be non-linear data structures. Hope you have understood what is meant by data structure and what are the two types of data structures. See you in the next video. Get connected.